For centuries, soldiers needed better protection. Today, it comes from advanced fibers, ballistic steel, and engineered armor plates. A modern ballistic helmet looks simple outside, but it is built to absorb impact. Then comes the body armor, decades ago. This process stayed behind closed doors. This is Nevsky, a Russian defense equipment facility. Behind the plane exterior is a company focused on research, testing, and production. It builds protective gear for real use. Helmet systems, hazard detection, impact pads, and pressure sensors are all developed inside this facility over the years. Nevsky has supplied large amounts of gear. One key product is a UHMWPE ballistic helmet. Modern helmets are no longer heavy steel shells. They use high-performance fibers pressed into a composite shell. The first step is feeding UHMWPE material onto the line. Hundreds of fiber bundles move together. In the center section, the weaving system forms the sheets. UHMWPE is strong and very light. It is among the lightest armor fibers. Its density is lower than water, so it can float. This helps make helmets lighter than Kevlar. It also improves impact resistance. Kevlar is still a proven armor fiber, but UHMWPE is lighter for its strength. After weaving, sheets are cut and rolled by controlled weight. In the next workshop, the material is trimmed again. Each time a sheet is pulled out, the cutter activates on the right. A plastic film removes trapped air. The cut then finishes under vacuum. Helmet pieces are smaller. Body armor panels are longer. Once ready, pressing begins. These fibers are stacked layer by layer. Resin helps the layers bond to spread out impact. A helmet needs many layers, so dozens of layers are pressed over the mold. After pressing, the shell becomes very rigid. Many ballistic helmets use this same basic method. The outer shell is UHMWPE, but the edges are still sharp, so finishing is critical. In the worker's hands, sharp corners are trimmed first. Then the front surface is prepared. Hand finishing is not perfect. An edge may be off by a millimeter, but protection is not affected. After the rubber trim is fitted, the helmet moves to painting. Common colors include green, tan, and black. Green suits woodland terrain. For desert regions, tan is more practical. Fresh paint is not ready yet. The helmets go on racks and cure for 24 hours. Strong lamps on the racks help speed up curing. The environment here is tightly controlled. Dust, heat, and moisture are limited. But in the assembly room, the work is more hands-on. Nearly 50 workers are here, working long shifts to install the inner protection. They also add the accessories. Watch this part closely. It shows the inner layer seating. There is no trick. It must lock in and stay firm. Next, the helmet reaches drilling. 6 or more edge holes are drilled. Some workers install straps, others add small fittings. Notice the drill shavings. Each piece is over a centimeter thick. That shows the UHMWPE ballistic shell has real thickness. This is not a thin stack. It takes careful layering. The green surface is fabric and paint. For tracking, each helmet receives a code. It links back to production records. The number is printed near the neck. For export orders, the batch number is printed. For domestic use, another code may be added above the batch number. It works like an ID tag, linking gear to its record. Can a UHMWPE helmet really stop around? First, a marker shows the test point. Then a controlled round is fired. The impact lands right on the mark. the surface shows little damage. Even inside, it stays mostly intact. After the helmet, the next item is body armor. Same facility, same workshop. But now, workers use a larger UHMWPE panel. These fibers protect chest and back. But larger panels cannot be shaped like a helmet. That is why this armor uses plates over vital areas. First, steel is cut to size. Then it is heat treated. The plates go into large drums. During tumbling, steel grit strikes the surface. Once the door is sealed, thousands of impacts happen inside. The surface is polished until it shines. To reduce corrosion and improve durability, workers add a coating. The coating is sprayed on. Then the plate is heated until the coating hardens. Now it leaves the rack and receives its protection rating. This is not ordinary steel. It is ballistic steel. Ballistic steel is made specifically for armor. Its hardness can reach 540 HB. Besides steel plates, some armor uses ceramic inserts and lighter protection systems. The P1 series is for police and law enforcement use. Now the ballistic plate is ready. During assembly, 5 or more padding layers are added. Foam and breathable rubber help absorb the force. Without these buffer layers, impact could still injure the wearer. This is the vest's outer carrier. It is usually camouflage fabric. So, how long does it take to build a full set? This craftsman has 20 years experience. He can assemble one in just over a minute. Front and back panels are similar. Both can carry ballistic plates. A US Interceptor vest weighs about 7.4 kilograms. Even soft armor can weigh 3 kilograms. His assembly time is 1 minute 29 seconds. Military and police armor differ. Military armor prioritizes battlefield survival. Extra weight is accepted for protection. Police armor favors mobility.